On to Chapter 5, Continuous Probability Functions. Okie dokie, now we're talking about the probability of being the area underneath a curve. So a cumulative distribution function, the CDF, the entire area under the curve is 100% of the data. But if you've got the curve and you only want to look from a range from A to B, that's going to be less than 100%. Maybe half of it, 50%, a quarter, who knows. But a CDF, now we're looking at cumulative distribution functions, and they are going to be a range from some number to another. So if I want this, if I want the probability of A straight up, with nothing to the left and nothing to the right, we're going to say that's just a 0. Because it's got to be some kind of an area. It's got to have some kind of a width and height. So if it has no width, then we're going to say the probability is 0. Okay, so chapter 5, there's only 2 lessons, 5.1 and 5.2. So 15, f of x is a continuous probability function. F of x is equal to 1/3, and the function is restricted to a domain of it's greater than or equal to 1, less than or equal to 4. So describe the probability of x being greater than 3/2. So kind of looks intimidating, but it's not bad. So here we go. 1, 2, okay, so this is going to be 1, 2, 3, 4, 5, and the function f of x equals 1/3. That means it's not very, if we call this 1/3 is like right here. Boom, boom, boom. So 1/3, I've got this horizontal line that goes forever. Now the probability has got to be 100%. So its height, I've already set the height. The height is 1/3. So 1/3 times what number is going to be 1? And that number is 3. So that means the width of this is going to be 3. So this little rectangle, if it's uniform, that's nice and easy. So I got this rectangle from 0 to 3. It's a third tall. And that's it. But they are going to change the domain. They're going to restrict it from 1 to 4. So that means from 1 to 4, this is where we're looking right here. They're going to start it at 1 and end it at 4, which is okay because that's 3 long and it's still 1/3 high and 3 times a third. So that does account for 100% of my probability. So describe the chances of x being greater than 3/2. So 3/2 is 1.5. So it wants to know what is the area under this curve right here. So this area, the width now of the shaded area is 2.5 times the height is 1/3, and whatever 2.5 times 1/3 is, that is the probability of landing anywhere in this shaded region. Okay, 72. Consider the following experiment. You're one of 100 people enlisted to take part in a study to determine the percent of nurses in America with an RN degree. You ask nurses if they have an RN degree, so it's a yes or no. Then you calculate the percentages of nurses with an RN degree. You give that percent to your supervisor. So part of it is discrete, part of it's continuous. Okay, discrete is something you can count. Continuous is something you measure. So count, this is going to be that you can count the number of yeses or no's. So that is totally discrete. I got 57 yeses, 43 no's, who knows? But you can count them. Now, it becomes continuous when you change it to a percent. So when you change to a percent, that is continuous because it's a percentage. If I had like 57%, even though 57 is a nice whole number, this is a measurement, so it's going to be continuous. So 73, this answers that better. So when age is rounded to the nearest year, so if I'm like 45 and 7 months, I'm going to actually round that up to 46. So 46 is a nice integer. Does that mean it's continuous still, or would that be discrete because it's a whole number? And the answer is, it is still, even if it's a nice number, it's going to be continuous because it's something that's measured. So age, if you're rounding, if you round it to a nice whole number, that's still continuous because your age is actually something you're measuring. If I were to count how many employees are 45, let's say I got 7 employees that are 45, that would be a discrete, something I can count. But age is something I measure, so it's continuous. And that's it for 5.1. 5.2. Okay, the uniform distribution, we kind of already talked about it. It's a rectangle. Area is going to be 1. This all is kind of funky looking, but pretty straightforward. Average is pretty straightforward. Again, the standard deviation is the one that we're going to have to maybe memorize. And the function is pretty straightforward. I mean, it's all pretty easy. It looks crappy, but it's pretty easy. So let's illustrate it with number 74. Births are approximately uniformly distributed between the 52 weeks of the year. They can be said to follow a uniform distribution from 1 to 53. So it's a spread of 52 weeks. So X is, and if we look back here, here's how we represent, right here, a uniform distribution, A and B. So X is a random variable with a uniform distribution, and it's got the parameters A and B. And A is the min, and B is the max. So 1 to 53. Okay, now graph it. Okay, here we go. So if you're going to graph it, they want you to go from 1 to 53, so that's 1. Blah, 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 blah. 53. Here we go. And how high up am I going with this horizontal line? Dun, 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 dun. And you better only be going 1/52, because this is 1/52 tall, and it is 52 wide, and 52 times 1/52 is equal to 1. The area's got to be 1. So C, y equals, we just did that, that's 1/52. That's the horizontal line. Okay, the mean, okay, the mean is halfway, so you're going to add them up. I'm going to add up, so the mean says this, mu, you do A plus B divided by 2, so 1 plus 53 divided by 2, and that is going to give me 27. So that means just right in the middle, so that one's pretty straightforward. It's the standard deviation. We're going to have to look on our notes. Okay, so standard deviation. Let me go back here. Standard deviation is the square root of B, that was 53, minus A, that's 1 squared, divided by 12. And who knows what that is. So give me a sec, let's crunch that in. 53 minus 1 squared over 12. Oh man. Okay, it is going to be the standard deviation, so they're going to vary from the mean 15.011111-ish. Okay. Oh, whoops. probably did not want to do that. Let me undo. I want to get rid of these boxes. How do I get rid of these boxes? Okay, let me erase some stuff. Okay, F. So find the chances that a person is born at the exact moment of 19 weeks. So X is 19. So somewhere in here, 19. But I have no width, so 0. I gotta have some range. It's gotta look like G. I gotta be between 2 and 31. So that's better. So 2 and 31. Let's say they want you to find the area of this guy right here. Okay, I already know the height. The height is 1/52. But the width, 2 and 31, I just do 31 minus 2. Okay, the width is 29. So it's just going to be length times width, 29 times 1/52 equals, times your tops, 29/52, whatever decimal that is. Okay, H is going to be kind of the same stuff. Find the chance that they're born after week 40. So week 40, 40 to 53, so 53 minus 40, so that's a 13 width times by the 1/52 height. Cha-ching, cha-ching. Okay, I is interesting. Let's look at I. I guess I should just erase it all. Okay, I. Find the chance that X is greater than 12. So here's my rectangle. Bonk. It's 1 to 53. Okay, find the chance that it's greater than 12 given that it's less than 28. So here is 28. Now, 28, I'm looking at all of this region here. So its width is 27. So it's 27 times 1/52. So it's 27/52. That is the area of the whole thing. Okay. Now, but they want to know the chances that it's greater than 12. So it only wants to know this region here. Okay. So between 12 and 28. So I'm going to go 28 minus 12. So that is 16. Okay. So it is 16/52 out of the 27/52. So just this portion out of the whole 27/52 portion. And whatever that is, you're in business. Because you're not going out of the entire rectangle, you're only going out of this portion of it. Only out of 27 of the 50-seconds, not 52 of the 50-seconds, if that makes any sense. Okay, J, find the 70th percentile. So that's just going to be, now this, here's what we got to remember. It's kind of a tricky question. This rectangle is actually 52 in width. We did shift it over once. So instead of starting at 0 and going to 52, we shifted it over and went from 1 to 53. But the spread is still only 52. So the 70th percentile is what I'm going to do. I'm going to do 0.70 times 52. And 70% of 52, 0.7 times 52. Okay, that's 36.4, but I must shift right once. So it's actually going to be 37.4. So that's my 70th percentile. K is the best. Find the minimum of the upper quarter. So if we divide this into quarters, like 25% here, 25% here, 25% here, 25% here, this is what they're talking about, the upper quarter. And the minimum they want right there. And that is 75%. So 0.75 times 52 is 39, but you're going to have to shift it right once, so it's going to be 40. And, okay, that's it. Sweet, that's it for chapter 5.